everyone, my name is Elena Ashton and I am the co-founder of Education Empowers, a nonprofit, which promotes STEM, robotics, and sustainability. I am also the captain of my high school robotics team as well as the chief science officer and STEM ambassador of my school. In the third lesson, we will cover how to program your own self-driving car using the ultrasonic sensor. We are going to start lesson 3, the self-driving robot car. So the main objective of this lesson is basically for you to learn to program self-driving cars using ultrasonic sensors. We're going to connect STEM to real-life self-driving cars and show how the technology works. But this is mainly to help kids to familiarize with the basic EV3 programming and to learn about the world of sensors. We also just want kids to have fun with competing and using the robot car. So sensors in self-driving cars. So how does a self-driving car work? How does it see? What makes the self-driving in a car? Well, what do the self-driving cars and robots have in common? Well, they have a lot of sensors. Self-driving cars can see and sense things around them using sensors. So sensors act like eyes and ears, but for cars and robots. Cameras, GPS, radar, these are all different types of sensors that the cars have. So a sensor is basically a device that detects and responds to some input from the environment. So for our programming for the self-driving car, we are going to use an ultrasonic sensor. So how does one work? Well, an ultrasonic sensor works like a bat using echolocation. It uses sound waves. It measures the distance by sending sound wave at a specific frequency and listening for that sound wave to bounce back. By using the time between the sound wave transmitting and receiving, the distance between sonar sensor and the object is calculated. So the distance to the object can be calculated, of course, using this ultrasonic sensor. So the ultrasonic sensor sends out a sound wave and it goes and it hits a wall or some type of object. Now once it hits the wall, it comes back and bounces back to the sensor. So this end of the ultrasonic sensor is actually transmitting a sound wave and this one is going to be receiving one back. So basically ultrasonic sensors work like a bat using echolocation. Our robot already has a ultrasonic sensor implemented, as you can see right here, but if your team does not already have an ultrasonic sensor on your robot, you can just go to this link or go to the LEGO website and build your robot with an ultrasonic sensor attached. So we actually have a very fun challenge for this lesson. So a group of friends are traveling in the mountains to visit a family in a remote town, but the weather changes suddenly and their beautiful train ride comes to a stop. They're stuck in heavy rain and mudslides. They open up their backpacks and take out their programmable self-driving robo-cars. The robo-cars can expand to fit them all. They need your help to program their self-driving robo-cars to reach the destination in the mountains, which is their home. Can you help? So just an overview, so this is the challenge route. So you start right here, and this is where the friends are stranded basically. And as you can see, they have to get to point B and then to point C, which is their home, their destination. But along the way, they have mudslides and just obstacles, making it hard for them to maneuver around the mountains to get to their home. So your objective is to make a challenge route on the classroom floor or table with tapes. Kind of like how we did with the speed racers, you're just going to make a track. You're going to have a start line and an end point, basically imitating your starting point where the friends get stuck and the end point, which is your home. So you're going to have different obstacles. If we're going with the challenge, it's mudslides with the friends, but you can obviously put whatever obstacles you need in there, something to represent basically the mudslides in the challenge. So as a team, you want to brainstorm what does your robot want to do. So you can either move forward and then when a sensor detects the obstacle, move to the next lane, or when the sensor detects the obstacles, it can move back and then move to the next lane. It can stop, so your team can make a ton of different options for what your robot wants to do when the sensor actually detects an obstacle. So you want to ask questions. Hey, why do we want to do this? You want to brainstorm the problem statements, hypothesize, design, build, and then test the potential solutions, which is all, of course, the engineering problem-solving methods. So kids will learn how to do this through the brainstorming. So we're actually going to go with option 1 for our programming, which is basically that when the sensor detects an object, it's just going to move to the next lane. So now we are going to go to programming. So we're going to just start with our program, Mindstorm Open. We are going to go and make a new project. So we're going to go over to this plus sign and we're going to click it and we're going to open a new project. So like always, we're just going to go over here and close the content editor. That way we can have more room for our project. So with our programming, we're going to actually start with a loop because we want the self-driving car to always work, right? We don't want it just to work once, we want it to always work. So we're going to go over to this orange section and you're going to go to the third block end, which is the loop, and you're just going to go click and drag it up. So little review, loops basically just make your program work for how many times it needs to work. So we're just going to keep it on for infinity because, like I said, we always want the self-driving car to work. You don't want it to stop working halfway through your track. So next we're actually going to go back and go back to the green section and go to the move steering block because we want the robot to move forward like an actual car would, right? It's going to actually run the track and go forward until it meets an object. So we're going to use the move steering block like we've always done, except this time we're going to go to the on for rotation section and go down to just on. This is basically just saying, hey, the robot's just going to move forward, not really for a number of rotations, it's just going to always move forward. Then we're going to actually program the sensor. So the sensor is going to be in the orange section actually because we're going to go to the weight block. So we're going to click on the weight block and drag it up and put it right behind the move steering block. So what we're going to do next is we're going to click the time, which is right here, and as you can see it opens up a ton of different sections that you can choose. But because we're using ultrasonic sensor, we're going to go to ultrasonic sensor. Then it's going to open up another mini section, which is compare or change. So for our program, we're going to go to compare and then distance in centimeters. So as you can see, we go from clicking the time, going down to ultrasonic sensor, compare, and distance in centimeters. So when you click this, you can see that the weight block has obviously changed to modify it for an ultrasonic sensor use. Basically what this is saying right now is that you're going to keep on going forward, and then when the ultrasonic sensor sees something that's within 50 centimeters in front of it, it does whatever you program it next. However, we don't want it in 50 centimeters in front. We want it to be somewhat close to it, right? So we're going to change 50 to 15. So this is now saying that if it's 15 centimeters in front of it, it's going to do whatever you program it to do next. So because we chose option 1, which was just to move on to the next lane, we're going to come back to the green section over here, and we're going to use a move steering block, which is again the third block in, and just click it behind the sensor. So what we're going to do for this is, because we want it to move on to the next lane, we're going to actually make it turn. So I'm just going to put 50 here and have it just change. So this program, or what the objective of this program is right now, is it's basically saying that forever, because we are doing a self-driving car and we always want the self-driving car to work, it is going to just keep moving forward, doing its own thing. But then when the sensor, the ultrasonic sensor, sees an object which is either 15 centimeters in front of it or less, it's going to change and move into the next lane. Okay, so now we're going to actually save our program. So you're going to just go to File, Save Project As, and for my project, I'm going to just label it Self-Driving Car, and I'm going to save it. So after you've saved your program, we are going to actually now download it and run the program. Alright, so after we save our program, we're going to download the program onto the robot, so that way we can run it. So I've already placed the download card into the USB, but I have to place it into the robot. So as you can see on the robot, there is a little section called PC, which is where the other end of the download cord is actually going to attach to. And once you plug it in, you should hear a little noise from the computer, but sometimes your computer doesn't make a little noise. So after we plug it into the robot, we are going to click on the download button, and a noise should also come from your robot saying that it's fully downloaded onto the robot. So after you hear that noise, you can just unplug the download cord and you can search for the program on the robot. So I like to go onto the project section, so I just click once to the right, and you can see a ton of different files with different names. So what you saved your project as should appear onto here. So I saved mine as self-driving car, which is actually the top one on the screen. So I'm just going to click the file, and underneath you should see a program. So I'm going to just go down and click program. So once I click program, my program should work. As you can see, I do have my ultrasonic sensor on, which is lit up, and the port is correct in my programming. Next, we're going to go back to the challenge with the friends getting stuck in the mountains and having to use their self-driving car to get out of the mountains. So I have a mini track right here. This is going to represent point A, where the friends get stuck, and over there is going to represent point C, which is their home destination. So if I actually run my self-driving car and say there's an obstacle, they should hit home right there. So I hope you guys had fun learning how to program your own self-driving car, and we can't wait to see you for the next lesson.